A wonderful good afternoon, dear LinkedIn community, and a wonderful good morning to you, George. George is
Morning.
joining us from near Denver in the US. He will talk about his company and his history a bit later on. Let me also greet with you Norbert Werle, who is an operator of air taxis. And we will talk today about the future of air taxis. A very exciting development going on. We have been in the media already, and now we thought we will also update our LinkedIn community. Let me start with our international guest, Norbert, with George, who is the manufacturer of a electric airplane in the future. George, how come you produce electric airplanes?
Uh, Such a wonderful opportunity with electric. The propulsion system from a internal combustion engine is exchanged with an electric motor and a battery pack, much like many of us are driving today with an electric car, an EV. The same kind of mentality with charging, the same kind of amazing efficiency and the lower cost of electricity can now be transplanted across from a car into an airplane. Of course, many very careful processes and technology to develop the airplane around safety and performance. But the major opportunity now with an electric airplane is emerging now, just like electric cars.
So that is wonderful. Thanks for the introduction, George. And now, Norbert, over to you. You are carrying out a hyper investment. I call it hyper investment because it's quite a volume here going on. So you ordered a few taxis, and you have some news with us to share today. What are the news?
Yeah, the essential news are on the one hand, the order of the airplanes, as you can see here, with George. And this is the eFlyer 800, a nice 8-seat airplane, super developed for the air taxi market. And our air taxi service that we have already here in Europe is going to a really nice price model of only 4 euros per kilometer. So that means comparable to a taxi ride, which is in Berlin at the moment starting with 2 euros per kilometer. We can fly you very time efficient and with 350 kilometers per hour right now already all over in Europe. And with such an airplane like the eFlyer 800, these times will be even much shorter, and it will be helping our future sustainable way of flying because they are fully emission-free, fully sustainable airplanes.
Okay, let me show the community just very briefly. We have a small snippet here how the plane will look like. It's very sleek design. So you see that aircraft in an animation. So Norbert, you have said that you want to disrupt the industry by offering a air taxi travel system for business travelers, leisure travelers. So how would that the charging work? Taxi runs on a road with a kilometer price or a minute price. Do you want to apply something similar to the air?
Yeah, it is actually quite easy to find out the distance between two airports. So you have, and everybody has Google Earth or Google Maps to find out the distance between the airports. And then you have the kilometers and just multiply that by 4. And then we see this is the possibility with a Diamond airplane, again, here. The Diamond DA42 that we already use today is a 4-seat airplane that we can use for such flights within Germany or within Europe. And this is actually the possible rate. So it's not as expensive as a private jet. And that's the main message, that time-efficient travel can already happen today with such airplanes, and we have a fleet of 20 airplanes that we are operating already today. So air taxis is not something for those vertical takeoff that might happen one day. It is something that is already true today. And all those vertical takeoff air taxis that you hear so much in the press, like Lilium and so on, they will still need a while, because even George will need now still a while to certify this airplane with just changing the propulsion system and changing then additionally the way of takeoff, eventually even the steering systems and so on. It will be a hell lot of work for those companies, still taking many, many years for all those vertical takeoff. We are happy to use them one day to transport our passengers to the airport for the last 50 kilometers, first and last 50 kilometers, and then fly the further distance with this airplane. But it will be still far off. And that's why we decided to go with such small airplanes and with the eFlyer 800, because those airplanes are the near future and the only way to make air aviation sustainable right now already.
So while we are hearing from you the news, the fantastic news for sustainable flying in the future, let me also at this time welcome our guests on this LinkedIn Live. I see there are a number of live watchers. They are concurrent here on this live. Unfortunately, there is a bug on this LinkedIn Live, not on my side, but on LinkedIn's side as I see it. Comments seem to be not working at this time, and I asked LinkedIn to look into that. So unfortunately, usually we have an interactive system here, and we would ask you for questions and your comments, which I'm sure you have plenty of, but the comment section seems to be on an outage right now. What we could do, you can check back on a replay and write your comments afterwards, and we make sure that Norbert, George, and myself will look into your questions and answer them straight away. Also, alternatively, of course, you can contact everyone. Also, today we are live on LinkedIn, YouTube, Facebook, Twitch, and I added Twitter the first time. I don't know how this works with Twitter, but let's see and surprise ourselves how it works. So if there are viewers from the other channels, you're welcome also to write your comments. I can't see them on StreamYard though, but we will look after them in hindsight. So Norbert, another question before we turn to George on the technical side, which is very, very important also, to analyze and then to see what's going on behind the scenes. So you've mentioned a rate of €4. What is it per kilometer? Yeah, that is roughly 5.5 maybe euros per mile. Yeah, if that is just a head guess. Yeah. So is this all inclusive? I mean, is this only for the plane rent, or is this including the pilots? What about the fuel?
It's really all inclusive. So this is a rate the same like if you would jump into a taxi and just from the airport or from any place in the city go to another point. You just look at the window, what is the rate, and then you jump in and you go. And that's the easiness that we want to also achieve for our clients, so that they just can pick up to destinations where they need to go, and we fly them there for the €4. Of course, there are conditions. So this is in case we are flying directly from our location where the airplane is located to the place with a 4-place airplane. If we use bigger airplanes, if you use international airports and so on, then we will need to adapt some price points on those €4, or going like for a 6-seat airplane, for example, to €5 per kilometer to do the same route. And that's why, like an example, going from Nuremberg to Emden one time totally across Germany would be 500 kilometers. And this is possible then with us for the €4 per kilometer to do this flight, even today.
Okay, that's wonderful. But how do you do this? I mean, there is a lot of cost if I may add this up. And for me, flying by airplane was always a kind of a luxury or premium segment of business travel, but it seems to become more and more affordable. How do you do this?
Well, today already we use, let's take one, and DA42. This is a very efficient airplane, and it's using much less fuel than a private jet or anything like that, because it uses diesel air engines, like normal 2-liter car engines that are adapted for the flying in the environment. And they are very efficient. And really, with such airplanes, and the sister model is a 6-7-seat version of this model, we can fly at a very low rate such distances and provide this individuality to fly really at the time that the customer wants it, to the airport where the customer wants, and also returning whenever this meeting is finished. All this we can do with such an airplane at such rates already today. And that's maybe then a handover to George, because George is promising with the eFlyer 800 only a fifth of the operating cost of today's turboprop airplanes. And this is, of course, what would then even slash the pricing significantly more once those airplanes are coming online.
Yeah, go ahead, George.
Yes, I think one of the fundamental benefits of electricity is the lower cost that comes from a grid that has created the energy efficiently as compared to a refined petroleum product, where the expense of the petroleum is translated across into the fuel cost, and therefore the operating cost of an airplane. So there's a contrast between electricity and petroleum in the cost of the energy, the cost of the fuel. This is shared across and benefits the operator of the airplane. So we have found in our flight test, we've been flying a prototype for about 4 years, 4 years now. The cost of electricity as compared to aviation gasoline, diesel fuel, or jet fuel is greatly, greatly reduced. About, in the United States, is about 1/10 of the cost for electricity as compared to a petroleum, avgas, diesel, or jet fuel. 1/10. When combined with all of the factors around operating the airplane or operating cost, it's about 1/5 the cost to fly electric as it is a conventional legacy aircraft. So Norbert's able to enjoy these benefits, the climate benefits with no CO2 emissions, the noise benefits of wonderfully quieter operating because, of course, there's no combustion noise, together with the efficiency and lower cost of electric. And that combined benefit is able to be passed along in their operations and costs to the passenger. So a great day for transportation as we go from legacy conventional fuels and airplanes to the future with electric.
Wonderful. We have, George, a question from our audience. So once again, I wrote now the sticker below. There seem to be some issues with commenting on LinkedIn Lives. I discovered it today or yesterday. We have right now over 20 live viewers. Thank you so much. Welcome to this show. And so we have a question that comes from Eric Pierjean. Eric is asking, which technologies challenges are the most important for the growth of the sector? Materials, batteries, capacity or weight, engines, productions of planes? Before we go to Norbert on this one, can you, George, tell us your opinion about that?
My answer to Eric is yes. All of those are a factor. Interestingly, the nose of the airplane for an electric is much, much sleeker than a legacy conventional airplane because there's no requirement for cooling that combustion-based piston. The electric has about 94 to 96, 97% efficiency, so the thermal or heat energy required, cooling of that heat energy generated, is greatly reduced. Flat plate area, parasite drag, all translates across to the reduced drag and aero efficiency of electric as compared to conventional. The eFlyer 2, the eFlyer 4, and the eFlyer 800 that we're talking about today all have very high efficiency ratings compared to conventional aircraft because they're very, very sleek. So it's not just the efficiency of the electric motor, it's not just material science and the advancing energy density of the new lithium battery cells. All of those, of course, are obvious and very, very important. But it's also the design of the airplane, the purpose-built, focused design of the airplane to take advantage of these improvements and reduce drag, the carbon composite, and the advanced aerodynamics and shapes of the airplane. All together, it's the science of the cells, of course. It's the new lighter weight, higher torque, purpose-built electric motors, yes. Advanced electronics and monitoring and safety, yes. But as you noticed the video just now, you can see it's a very, very sleek airplane, and that contributes to performance and efficiency as well.
Wonderful. Thanks, George. So, Norbert, from your perspective as an operator, what is your stance on Eric's questions?
Well, the most technology challenges for us at the moment are more on George's side because he needs to develop those. So we tackle a totally different challenge because the challenge is at the moment that private aviation has this view on, okay, it's only the private jet and the CEOs of the world that are flying there. And this is an attitude that we are changing right now already in those 4 or 5 years that we need to wait for the developments of the Aerospace airplanes. But we are now already giving the people the opportunity to fly privately and at a reasonable cost, because if you calculate your time savings and your additional costs that you have usually in a business trip, usually our flights are already cheaper. Of course, if we compare it to a trip where the ICE is directly connecting city center to city center, or you go from Frankfurt to Berlin where the airliner is running fast, yeah, those are the better options then. But everything else, which is a little bit further off, is already today extremely economically reachable by our airplanes. And this is the challenge that we tackle right now. And we need to see who on the market is really the first one that is giving us an electric airplane that is allowing us to fly totally emission-free. And because the aim of Air2E is from the beginning to go electric and sustainable with those airplanes. And from our view at the moment, the eFlyer 800 is exactly what we need. That's exactly the airplane that is developed to fulfill the needs that we have. We don't need a big 19-seat airplane that even longer will take because of the battery technology that is still needed there. We need something like this airplane that is in the background here. And George is having certain criteria for the development and a road which is tackling all those challenges that we saw now here. And probably the battery is one of the main ones for sure for the next times.
Yeah, Norbert, but let me challenge you a bit, if I may, because I'm myself a heavy business traveler, as you know. As a business traveler, time is essential for me. I don't have time to wait that your electric battery is fully loaded again. So what is the turnaround time of your plane? If I have a meeting, say you jump me somewhere at a regional airport, I go to the customer, supplier, network partner, whoever, and I want to go back maybe even in the same afternoon. Yeah, you're talking about a taxi, and taxis give you the flexibility of jumping somewhere and jumping back. How long is the turnaround time? What is the plan here?
Well, from what I discussed with George, and correct me if I'm wrong, we would be able to do this in approximately 1 hour or even less than 1 hour to charge the airplane. So at the moment, we work always with at least 45 minutes turnaround time at the airport with those airplanes, because we need to taxi, we need to wait for the fuel truck to come there, we need to unload the passengers and everything. So if we, like today with the car, drive or roll to the charging point and have 2 fast chargers there, then we will be able to charge in exactly the same time as it is today. But let George explain how the charging will be done.
Yes, I think that's a great question, and what's interesting is that I just purchased a electric car, an EV, and we get about a half charge with that with the EV, with the electric car, in about 15 minutes. So the level 3 superchargers that we see so often now across the states and our metro areas across Europe are allowing a relatively quick recharge, even of 50% of the capacity in about 15 or 20 minutes. That translates to aviation as well. Of course, when we stop for petroleum as a gasoline station, we expect to recharge or refuel in just a relatively short, few minutes time. But in aviation, as Norbert points out, the turnaround time of passenger loading and unloading and luggage, the process of flight planning and preparing for flight is a little bit longer. And it turns out between 30, 45 minutes or an hour is typical for turnaround time when loading, unloading passengers and luggage and so forth. So we can well manage the charging of an electric airplane just like we do an electric car. And obviously we don't use up all of the energy in the battery, so we're not recharging from 0 to 100%. Usually we're recharging about half of the energy stored. So it turns out the turnaround time, not too bad.
Yeah, that is wonderful news. And let me also joke a bit now. Um, First of all, like you said, you will not fully utilize the electrical charge, depending on, of course, the travel distance you are going to have. But that also doesn't mean that you have more weight on the plane. The weight is the same. And in future, there's also less risk of, you know, misleading units like liters and gallons. We know these popular issues that happened in the past when the plane was filled up with liters instead of gallons. Yeah, the numbers, and then suddenly half.
Surprisingly, we've seen problems like that. It seems
It's
silly to
real.
even mention it, but it's true. It does
It's
happen.
real. Yes, the danger is real. Absolutely. So let me come to my technical heart, George. Maybe Norbert told you up front. I have very lively community here on LinkedIn based on composites. And composites, I mean carbon fiber reinforced polymers or plastics, or glass fiber reinforced polymers and plastics. Do you use these technologies?
We sure do. In fact, we use a Toray type of composite on the eFlyer family of aircraft, much the same as Boeing and Airbus and so many others. This advanced material is very light and strong, and has characteristics even that are beneficial beyond aluminum that has been the traditional aircraft structural material. So we're very happy about that. The aircraft get lighter and stronger. The shapes of the airplane, as I mentioned earlier, very sleek. And these characteristics with composite are much easier to form in the tools and the molds that the airplane is created from. So very exciting future. It's not just the electronics, it's the aerodynamics and the shapes and the structures that support it.
Okay. Can I have a bit more detail on the composite that you're using? Is it first of all the carbon? Is it a carbon fiber? Do you have hybrids like carbon and glass? And what is the makeup? Is it a pre-preg that you're using? And if so, have you ever considered thermoplastics instead of thermoset production?
The, the very good points and questions, and the answer again is with a smile. It's yes. Um, Depending on the part of the aircraft you're referencing, whether it's a primary structure, a secondary, or just a form, a door, for example, non-structural door, the choices and uses of the materials will change. Even a fiberglass type of material can be used. A primary structure like a wing spar, the bridge that the airplane's built upon as it flies, that wing spar, oh my gosh, the very, very finest attention to detail in that structure material, the Toray composite, as I mentioned. But as you go beyond primary structure into secondary and third level of parts and pieces of the aircraft, the choices of materials align with the type of structure or part that's being created. And some of the forms inside the cabin, for example, are for convenience or for aesthetics. These are non-structural, and we try to save weight and cost, of course, as appropriate to create the best possible product, the best possible cabin experience for the customer that I'm preparing for Norbert's operation.
So you're talking about the best possible experience. Totally agree with you. Some of the annoyance in an aircraft is the noise inside the cabin. How does composites contribute to increase or decrease noise levels inside the cabin?
Composite materials in and of themselves are not problematic. How you insulate and isolate materials and the airframe noise, the vibrations that translate across from the airflow across the exterior of the airplane are insulated and isolated properly in a good design, and the cabin environment is benefited with this proper approach. Fundamentally, electric aircraft do not have combustion noise. We know this from electric vehicles, trucks and cars, of course. They're silent, and the wonderful benefit to airplane experience is translated across just like it is with an EV. This is very important.
Norbert, can you add to the comfort of passengers? Have you made this to your purchasing criteria when selecting by aerospace?
Well, the noise issue is certainly an issue because even today we would be very happy to have even less noisy airplanes because some airports have significant restrictions because of noise. So we cannot land in the night. We can, some airports have a restriction of only so many movements per day, and all because of those noisy combustion engines. And essentially, with such an airplane, you can land at many glider airfields later because this airplane will be not much more noisy than a glider. Only during short times at takeoff and landing, you will hear the prop noise, and that's it essentially. And therefore, it is for us really significant system immanent feature of electric propulsion that the noise issue is suddenly almost gone.
Wonderful, because I got a small airfield here, Rosenthal Airfield. I told you, Norbert. Rosenthal is a porcelain manufacturer. They have their own airfield here. It's used mostly for hobby, but you can't imagine on the weekend what traffic I have over my house with all these, small sport planes. And I wish in future they are all electric, so I'm not disturbed when I do my barbecue with my neighbors in the future. Wonderful experience. But let's come back to George one more time. George, I have a question from one of our viewers, Wilfried Eckel Dorner. He says, so far, no airplane with electric propulsion has, to my knowledge, gotten any approval at all from aviation authorities. All of them are still in the prototype phase. How is the situation with Buy Aerospace? Do you already have a working prototype? And before you answer, there had been some debate going on from a LinkedIn user. He says this is not entirely true. The Pipistrel Velis Electro received a type certificate from EASA and is already in service. Now, for me, as a composite nerd, but not so much into this detail of aviation regulations and these acronyms that have been used, can you walk us through what was asked here and what is your stance on this?
Yes, the regulations for flight authority and for airplanes to operate are covered well in the United States with the Federal Aviation Authority Administration, FAA, and our friends in Europe under EASA, the European equivalent. The normal category of certification is contrasted with the Pipistrel aircraft, which is a light sport or recreational airplane, and experimental airplanes that have had electric propulsion. We have flown a prototype for 4 years' time. Three different motors, 2 different battery packs, and have vigorously, with rigor and engineering detail, examined the benefits, the technology, the mechanical systems around electric propulsion. So we've been flying for a long, long time. In fact, even years before that, a developmental prototype single seat and a conversion of a Cessna 172 to electric propulsion some years ago. So we've been doing this a long, long time. But the readiness of the regulation for a normal category aircraft, one that can be fully used in business, just like Norbert, and put into commercial use with passengers for hire, for professional pilot training to the highest level as an airline pilot or commercial pilot. This requires a normal category certification, and EASA under CS23, it's a regulation, and the FAA under 14 CFR Part 23 has a new Amendment 64 that just a few years ago was passed and allowed to create a roadmap for a normal category aircraft to be certified and put into service. Buy Aerospace was literally the first company in the world to make an application for this fully normal category aircraft with the FAA, April of 2018. We're well underway in this process with the design of the aircraft submitted, the testing and certification process submitted and agreed. We just completed the last 16 of 16 system-specific certification plans. I know that's a lot of technical engineering speak or regulatory speak, but the idea is that the rigor and depth of review for safety and technology is fully embraced through the FAA and EASA to prepare the best possible safe outcome for a fully normal category certified aircraft. The eFlyer 2, the 2-seat primary trainer, will be the first aircraft, followed by the 4, and of course the eFlyer 800, built on that same technology roadmap as the 2, the 4, and then the 800.
Wonderful. So we have comments coming in. So I'm really glad that comments seem to work. Maybe someone, Marcus, who wrote this comment, can you write please in the comment just as an internal note? Are you in with your mobile phone or with your desktop so I can see where the issues from the comments are coming? So Marcus says, thanks for your talk. Assuming a reliable transport system, you need to fly in IMC conditions too. Do you have any idea on additional power consumption needed for de-icing?
Anti-ice or de-icing, radio transmission, lights, heat, and environment like pressurization, all are important features of aircraft, any aircraft, including electric aircraft. They do have a power draw. What's interesting, of course, is when you contrast that power draw to the propulsion system requirements, it's relatively small. It's almost trivial. It seems like it might be a lot of energy, but in contrast to the propulsion system, very, very small. So the battery pack size, of course, is created to match the mission requirements. For example, again, the eFlyer 800 to do the 500 nautical mile mission at 280 knots normal or up to 320 knots speed in high-speed cruise. The primary driver for the engineering and the preparation for this proper battery module size is mostly around the propulsion system. And of course, there are margins left to account for radios, for heat, for the lights, and of course for de-ice and anti-ice, because we expect our friends in Europe and across much of the United States to be able to operate in what we call IMC, or cloudy, non-clear sky.
So let me ask then Norbert, because he represents now the German-speaking markets, and he will offer these services across Europe. So what is your stance as an operator and as a past pilot on this one?
Yeah, absolutely. This was a very important question, and I also want to draw the attention to our possibilities even already today. So even if some people think that only the big airliners can operate safely in icing conditions and in total darkness or cloudy conditions, rainy conditions, no, we are flying really already today with those airplanes in all those conditions and doing this safe over the Alps, over all over Germany, all over Europe. And of course, we need such systems in the airplanes. We need to have a system that is clearing the wing from the icing. But we have that already today with a liquid that is flowing around the wings on our airplanes that we operate today. Some have boots on it that is like on the big airplanes, getting off the ice by blowing up a little bit the wing. And so those systems are existing, and of course it is extremely important for us that also the future electric airplanes will provide us the same reliability, because that's exactly what is, for example, such a small Velis electrode that we heard before not able to do today. It's a recreational airplane for flight schools, for flight training and so on, but it would not fit our purpose of having a reliable transportation service for our clients. And this is a requirement certainly for George, but he is fully aware of this, that we need to have those airplanes able to operate from the south of Spain until the North Cape in the total north of Scandinavia.
Wonderful. So you know our next trip where it goes to. George, we have a new question from Markus Feileth. Markus, thanks for your engagement today. Wonderful. It seems to be you are a aerospace professional here and composites at the same time. So concerning composites, is there still the need of electrostructural network ESN due to lower conductivity of CFRPs? Is there a significant weight impact if so? So my question is, why do you need an electrostructural network on a plane at all? Has that to do with the lightning strikes?
So HERF and lightning, the electromagnetic fields created, of course, and the static electricity built up around the airplane as it flies are all known conditions for aircraft and aircraft design. Of course, we've used composites of various types with copper mesh and other mechanisms to address the electromagnetic fields, lightning strike, and the ability to dissipate the static electricity that's built up as we fly through the air. So this is very well known. It's been something that's been a part of airplane design for decades, including now, of course, composites that Boeing and Airbus and so many of the other major airline manufacturers are using and well aware. We take that one more step because we have a higher energy field built up around the electric motors. And so there's a great deal of attention around those fields and the ability to shield that energy from systems like avionics and radios and things like that that the pilots are needing to operate the airplane on a normal basis.
Norbert, did you already exchange local airfields like the Rosenthal that I mentioned to you? Is it possible to land with this one on a airfield as small as a Rosenthal airfield?
Well, that's one of the requirements also to George to have as short as possible runway lengths for the future airplanes. Today, we require 800 meters of runway length. I would need to check actually Rosenthal Airfield, what's the length there. But certainly already more than 200 airfields in Germany are available for us today. And shortening this 800 meters to something like 600, 500 meters would even give us additional potential of several other airports. So yes, it is focused, but so far we need to show the airports how silent such an airplane is, because only the moment that the people are really experiencing the benefits of electric aviation, they will start to believe that now suddenly those airplanes are only short visible and almost not hearable.
Yeah, wonderful. Okay, so anything else, Norbert, you want to relay on our community here on LinkedIn that you find is very important to know about electric flying, sustainability, business travel in the future?
Well, it's really a start of a change right now. We would like to have aviation as soon as possible sustainable and emission-free. And this process we started with Air2E already a while ago in 2018 to give our clients the possibility to fly with such efficient aircraft like the Diamond to their business meetings. And now is the time to go one step further, because George has such airplanes like this eFlyer 800 here already. And in articles like today, the Handelsblatt, we discuss already with the Handelsblatt what benefits the business traveler has really from such flights. And so far, I can only encourage everybody to utilize our service more to get the experience how flying in an airplane that small but also that individual is, and getting us ready for the times when we can fly with those electric airplanes fully sustainable.
Okay, wonderful. George, we have a final comment that I will show up from Markus Feiler. He says there's on the A350 several hundreds of kilo of metal for this ESN. So, but as far as I understand, in your case, you have already designed it, so it's a very low weight, if at all.
Yes, that's correct. The electromagnetic shielding has been a very keen focus for us, and as I have said, we've been flying for some years, so it's well known to us. The copper mesh embedded in the carbon materials is very adequate for the job and is a standard approach. Of course, there's other approaches, as I've mentioned before, well known within the aviation community for these kinds of electromagnetic and electric static kinds of requirements.
Okay. So, George, what is your policy on your aircraft manufacturing? Do you have open doors so that we can have a look inside such an R&D and operation?
Well, I think, of course, transparency is very important so that people, our customer community, our friends in the aviation community can understand the benefits of electric and the details required, the challenges that we've met, and the potential outcome, of course, for transportation today and well into the future. This is very, very exciting. Obviously, it's a competitive environment. We're a business, and Norbert's a business, so I want to make sure he has everything possible that he might need to do his business and understand the benefits of the design in the airplane. Of course, in terms of inviting competitors, we try to be a little bit careful about that.
Yeah, but this calls for a visit of Norbert and myself in your factory, so we
I
can.
would welcome. Yes, of
So we
course.
can.
It would be an
So
honor.
the operator can inspect, and me can inspect your composites working in a real application, and we can relay this onto our community here. So thank you for the community, first of all, for watching this LinkedIn Live. Although there had been some, minor issues with the commenting. If you have tuned in later during this LinkedIn Live, just wait a few more moments. Then this LinkedIn Live will be available as a replay on LinkedIn, YouTube, Facebook, Twitch, and Twitter right now. It was a very, very fascinating and inspiring discussion. It's very great to see that the aerospace industry is looking into electrification. Whether the entire industry will follow electrification remains to be seen in the future. Huge airliners, they are looking into hydrogen like Airbus is doing right now. But for me, I'm very confident that electrification in this field of business travel, point-to-point travel, that is definitely the future. Yeah. What are your call to actions, Norbert and George? Norbert first.
Yeah, let's fly is the call to action, because we need to have the market already prepared. Any innovation needs to be purpose-driven, demand-driven from the market, and that's what we started off with. We don't want to wait. We want to fly today. We want to serve our clients really with a better time saving and more comfortable timing. And now comes the question.
Yeah, let's take this one final question, one more, that is directed to you, Norbert.
What is your need for ground support at small airfields? Well, at the moment, we have no ground support needed at small airfields at all. So that's one of the big benefits for our clients at small airfields. They park the car at one side of the fence and walk over through the fence to us and jump into the airplane. And even on bigger airports, we have general aviation terminals, and it's a matter of being 15 minutes before the departure at this terminal. And where you can wait in the lounge and be greeted by our pilots and led to the airplane, and immediately thereafter a takeoff is possible. So really, those are the big time advantages and comfort advantages that we can provide already today. So you don't need to drive long hours to the next big airport, wait in the queue and be 1 hour before departure there. You can be much, much more efficient. And that's the cue of this whole timing that we talk about. If you have a trip from one remote position to another remote position, you save so much time. You have, instead of 6 hours of traveling time, maybe only 1 or 2.
Finally, back to you, George. What is your call to action?
Well, thank you. We appreciate this time together, and of course, our great friend Norbert and Air2E. This is a perfect example of what comes next. Electric aviation has tremendous benefits in economics, in the climate change, the environment around the creation of pollutants is largely corrected because there is no combustion with electric aviation. So that the maturity of the technology, the readiness of the design and the certification process with EASA and the FAA creates now for the first time this great market. And we're just honored to work together with great people and great customers to bring this new generation of technology now applied to aviation. So our call to action is to stay the course, to drive to the future and create this new possibility for the aviation community and transportation in general.
Wonderful. Nice last word. So thank you so much for everyone for tuning in. Thank you, George, for tuning in from Denver this morning. Norbert from Berlin, our main capital in Germany. I wish you all the best. Let's hope that these planes will be in the air soon. And for the community, I have a last video to show, and we will say goodbye already now. Just have a look at this video. That was a documentation, if I'm not mistaken, on German TV. Bye bye.
Die Dienstreisen der Zukunft. Reisen wir im Hyperloop? Fliegen wir im Flugtaxi? Oder brauchen wir dank Videokonferenzen, Homeoffice und ständiger Vernetzung gar keine Dienstreisen mehr? Für viele Berufstätige sind innerbetriebliche Dienstreisen längst keine angenehme Erfahrung mehr. Vor allem große Unternehmen haben durch Fusionen oder betriebliches Wachstum Standorte, die zwischen 300 und 1000 Kilometer entfernt und oft abseits der Hauptverkehrswege liegen.
Ich fahre heute von Heidelberg nach Chemnitz.
Für mich geht es nach Wilhelmshaven.
Ich reise jetzt noch weiter bis nach Rostock. Also ich komme gerade aus Ingolstadt, steige jetzt um auf den Flieger, dann geht es nach Hamburg und dann steige ich nochmal um und dann geht es weiter bis nach Rostock.
Also am meisten nervt mich natürlich, dass das völlig verplemperte Zeit ist. Man ist ewig lang unterwegs.
Das Umsteigen, in meinem Fall 3-mal auf dem Weg nach oben.
Die Reisedauer ist so in etwa 7 Stunden. Ja, und das ist wirklich sehr nervig, weil man wird halt auch mal wieder rausgerissen, man kann auch unterwegs nicht wirklich arbeiten.
Ich fliege die Strecke nicht, weil ich der Meinung bin, dass ich dadurch keine Zeitersparnis habe. Ich müsste über Hamburg fliegen, was bedeuten würde, dass ich 2 Stunden früher Flughafen sein müsste und dadurch unterm Strich länger unterwegs wäre.
Wir haben uns mit den Dienstreisen der Zukunft beschäftigt. Als früherer Vertriebsleiter bei Nordex Windenergieanlagen hat Norbert Werle ebenfalls genau diese Erfahrungen gemacht. Wir haben ihn auf seiner Mission, Dienstreisen für Unternehmen zu revolutionieren, begleitet.
Damals bei Nordex gab es für uns nur die Möglichkeiten, mit dem Auto, der Bahn oder dem Linienflugzeug weite Strecken zurückzulegen. Ich habe selbst viele Stunden Arbeitszeit sinnlos an Flughäfen oder im Auto verschwendet. Dabei ist die Lösung doch so einfach wie simpel. Individueller Luftverkehr.
Ein häufiger Irrtum ist, dass On-Demand-Fliegen nur mit teuren Business-Jets möglich ist. Er erzählt, wie er die Zukunft der Dienstreisen in der Luftfahrt sieht und wie er sich in das Fliegen verliebt hat.
Wie können wir schnellstmöglich eine saubere und nachhaltige Luftfahrt etablieren? Das ist für mich die Kernfrage. Meine Leidenschaft zum Fliegen begann als Kind. Später wollte ich selbst fliegen, machte meinen Flugschein und lebte meine Passion im Kunstflug. Auf Dienstreisen wünschte ich mir als Pilot oft, dass ich schneller direkt zum Ziel fliegen könnte. Doch das war nicht kostengünstig möglich. Meine Arbeit, die regenerativen Energien voranzubringen und die Abhängigkeit von fossilen Rohstoffen zu beenden, war mit dem Carbon Footprint bei Flugreisen nicht im Einklang. Daher ist es für mich ein großes persönliches Bedürfnis, mit Air2E einen Weg zu nachhaltiger Luftfahrt zu finden.
Seit 2017 bietet Air2E nun sehr erfolgreich und regelmäßig individuelle Shuttleflüge für Unternehmen an und hat damit geschafft, was viele nicht für möglich gehalten haben: individuelle Luftfahrt zum Economy-Tarif. Für seine Firmenkunden setzt Air2E vor allem auf kleinere Geschäftsflugzeuge, die europaweit mehr als 2000 Flugplätze anfliegen können. Kürzere Wege zum Flugplatz, private Terminals am Flughafen und direkte Flüge zum Ziel ermöglichen Dienstreisen in unter 2 Stunden, die mit herkömmlichen Verkehrsmitteln 5 bis 8 Stunden benötigt hätten.
Mehrere Kunden berichten uns, dass sich die Beziehung der Mitarbeiter verbessert hat. Ich meine, wie einzigartig ist das, wenn eine Firma ihren Mitarbeitern eine eigene Airline bietet? Individuelle Flugverbindungen sind der erste Erfolg auf dem Weg zur nachhaltigen Luftfahrt. Denn nur mit dezentralem Luftverkehr in kleinen Flugzeugen ist es möglich, bereits in Kürze Elektroflugzeuge einzusetzen. Das ist das Ziel von Air2E, kommerzielle Flugreisen mit Elektroflugzeugen, und wir sehen die Chance, bereits 2025 wirklich grüne Flugreisen anzubieten. Natürlich wollen wir den Weg zur nachhaltigen Luftfahrt so schnell es geht ebnen. Wir suchen daher innovative Unternehmen, die weite Strecken auf ihren Dienstreisen zurücklegen und die sich dieser Revolution der Luftfahrt anschließen möchten. Wenn Sie jetzt gerade zuhören, und Teil dieser Innovation sein möchten, dann melden Sie sich doch einfach unter air2e.com. Sehen Sie selbst, welche Strecken für Sie möglich wären, und wir sprechen gerne ganz unverbindlich darüber, wie auch Ihr Unternehmen von individueller Luftfahrt profitieren kann. Ich freue mich darauf, Ihr Unternehmen und Ihre Reisegeschichten kennenzulernen.
IMBEO Passionate B2B Partnerships. Das LinkedIn Live Videocast Format mit Praxiswissen für Gründer, Unternehmer, Geschäftsführer und Führungskräfte aus dem Mittelstand rund um Innovation, Selbstführung, Leadership, internationales B2Business Development und nachhaltigem Netzwerken mit und auf LinkedIn. Präsentiert von deinem Host İlkay Özkesaoğlu aus Bayreuth.